Okay, so now we are on number 11. We're going to start at 11. What's that? All right, it says a circle has a radius, so let's write that down. A circle has a radius of 7 centimeters, and you have to find the circumference. I'm on number 11. All right, so you got to find the circumference. Well, you got to know what the circumference is. No, I don't. Well, so circumference is, now I'll probably give you a formula for this, but you just have to know how to use it. Okay, circumference is 2 pi r, and if you know that, then you should be good to go. So circumference C equals 2 times pi times the radius. Well, they gave you the radius. Freddie, take a pass. Don't just walk out. So it's 2 pi r. R is 7. Now watch. It's as easy as this. It's very, very simple. 2 times 7 is 14, and it's just 14 pi. If you just want to keep it 14 pi, I'm perfectly fine with that. You don't have to multiply 14 times 3.14. Right? You don't have to put that into a calculator. If you just want to keep it 14 pi, I'm perfectly fine with that. Don't leave it like this. Don't leave it 2 pi 7. All right? You can multiply 2 times 7 to get 14. You can leave it like this. That's perfectly fine if you want to. Now, if you really have a hang-up about leaving it like that, you don't like it, you could always do it this way. You could go 14 and then pi. The pi button is right there. I hit second function that and hit equals. So it's about 43.98. We'll write 43.98. So you could write it like that as well. All right, I would accept either one of those, but why bother? Wouldn't you agree? Why bother putting that into a calculator when I'm allowing you just to keep it 14 pi? You don't even have to pull the calculator out to do that. So my preference would be that you just keep it like that. But if you really, really have a hang-up about it and you want to, you could put it in a calculator and get that as well. All right? So that's number 11. Let's move on. Number 12. About 5 times, yes, I said that. Number 12. Let's write the little picture down that they have. This is L, this is M right here, and this is N. But it says find the value of y. Well, let's put the values in here. This is 9y minus 4, and this is 6y plus 5. Now, if I just put them right on top of these lines, LM is the 9y minus 4. Everybody see that? It's not the whole thing. It's just from point to point. So that part from here to here is 9y minus 4. This part right here, M to N, is 6y plus 5. Everybody understand that? Now, you also have to read on a little bit about it. It says M is the midpoint of Ln. So it says M is the midpoint. We've talked about that quite a bit in here. If it's the midpoint, all right, it's halfway, but it divides that whole segment into what? 2 what? Equal parts. Very good. 2 equal parts. All right? So that means that this is what? I don't care what the answer is. I'm trying to figure out how to get to the answer. All right? Answer my question. This and this are what to each other? They're equal to each other. Okay? That's what I want you to get. All right? Just me telling you what the answer is not going to help you. All right? You got to know that they are equal to each other. Why are they equal? Because M is the midpoint. If this is the midpoint, these two segments have to be exactly the same. So this and this are exactly the same. So that means I set them equal to each other. All right, and then you just do the math. It's no big deal. Subtract a 6x from both sides. That's, or I'm sorry, not x, but y. Used to using the x all the time. So subtract 6y from both sides. I get a 3y. Add a 4 to both sides. I get a 9. Divide by 3, and there is the answer. It's y equals 3. So the geometry was the easiest part of this. The geometry was just understanding that this and this are equal to each other. All right, and why are they equal? Because M is the midpoint, and that's what you have to know. All right, seems pretty simple, right? Number 13. All right, let's draw this stuff out. Let me draw this picture for you. Let's do this in white so it stands out a little bit better. So this looks like this. I'm just redrawing this picture is all I'm doing. And let's extend this one down about like that. Alright, let's put some letters in here. This is F and D and E. This one right here is B. It says this is a right angle. And this is A. And this is C. Alright, I think I covered everything. So we use this picture for two problems, for 13 and 14. So 13, go back to the purple here. 13 says, which angle is a vertical angle to angle ABC? Angle ABC. So it says, which angle is a vertical angle? Vertical angles, you should know what that means. Remember this? If I have two lines that intersect each other, then the angles that are across from each other are vertical angles. Everybody see that? Okay. So let's look up here. First of all, let's find angle ABC. ABC, that would be this angle right here, wouldn't it? And I have to find the angle that's a vertical angle with that angle right here. Well, it's got to connect. Look, it touches the same two lines as the other vertical angle touches. Everybody see that? So some people did this. Would that be a vertical angle with this? No, because look at this one. This one touches this BF. Does this angle right here touch BF? No, it doesn't. So that would not be right. So this looks like it could be. Are they vertical angles? Yeah, absolutely. Okay, let's take a look at why. Because look at this angle right here. DB, this hits DB, and this also hits DB, doesn't it? Right here, DB or BA, it's the same exact line. So it hits this line, hits this line going across, so yes, they are both vertical angles. So how would I name it though? I don't just mark it on the picture right here. How would I name that angle? So it's angle what? What would I call that? DBE, correct. DBE. Or you could go backwards on it, couldn't you? You could call it EBD, doesn't matter, I'll accept either one. But those are the only choices, either DBE or EBD. There's no other choice for that. And that would be a vertical angle with the angle that they give us. Alright, so there's no math involved. You just have to understand what is a vertical angle and how to name the angles. If you know how to do those two things, you should be fine with that. Alright, let's get rid of this stuff, and we got one more problem with this picture. Get rid of all that. Alright, number 14. Number 14 says if angle CBF is equal to 6x plus 18, find the value of x. I'll just put x. And that's all they tell you, isn't it? So let's find angle CBF. Alright, I see it. Watch. CBF starts at C, goes to B, goes to F. So that angle right there is 6x plus 18. And we have to find x. We have to solve for x. Well, what do I know about the value of this 6x plus 18? It's equal to 90 degrees, isn't it? Okay, because it got a right angle symbol right there. Alright, so this angle, 6x plus 18, is the same angle as this right angle. So this has to be a right angle. So it's got to be equal to 90. So 6x plus 18 is equal to 90, and now I just solve for x. Let's do the math. Subtract an 18 from both sides. Okay, that cancels out. That's a 6x. That's what, 72? Then divide by 6. What's 72 divided by 6? How about 12? Alright, so x is 12, and then we're done. That's all there is to it. The arithmetic's pretty easy. The geometry is just understanding what to set equal to it, right? So you looked at it, you said, hey, wait a minute, that's a right angle. They told me it was a right angle, so that has to be equal to 90 degrees, so I set it equal to 90 degrees. I work it out, and there we go. Make sense? If you got any questions, let me know. Nobody's asking me any questions, so I'll just assume that you follow what I'm doing. Again, a reminder from yesterday, even if you got these problems right the first time around, I would still do them again just to make sure they're fresh in your mind so that you still know how to do them, because it's been a while since we've done this stuff. So I would really, really try to do these again. Alright, here we go. Another picture. Let's draw this picture out. It looks like this. something like that, something like that, and like that. All right, let's label this ABC down the bottom. And then we've got DEF across the top here. So that's D, this is E, and that's an F. All right. And let's see what they tell you in the instructions. It says in the figure, it says BA and BC are opposite rays. What in the world does that mean? BA, right there, and BC are opposite rays. What does that mean if they're opposite rays? What kind of angle does it form here? What kind of line do we have? It's 180 degrees. That's right. If they're opposite rays, that means it's a straight line, okay? And it's 180 degrees. That's pretty important. But it also tells you something else. I'll write that part down. BF. It says ray BF bisects. Now that's an important word right there. It bisects angle CBE. All right, so let's take a look at that. Let's find CBE first of all. Here's CBE. So this right there is the angle that we're bisecting, okay? But what bisects it? BF, this one right here. Let's change color of that just so we see it a little bit better. And right there, okay? So this one right here bisects, and we'll change that color too. See that yellow one? It bisects that big yellow angle right there. Now if it bisects it, what does it do? Does it just go anywhere in between there? Splits it into two equal parts, okay? Michael's listening, okay? Because that's exactly what I was thinking. Splits it into two equal parts. So let's write some more stuff down. What else do they tell you? They tell you, let me find it, number 15. They tell you that angle 3, oh, I didn't write the angles in here, did I? 1, 2, 3, 4. There we go. Angle 3 is equal to 6x plus 4. All right, and they also tell you angle 4 equals 7x minus 2, and we have to solve for x. It says find x. That's right. Okay, so look at 3 and 4. Now remember, this yellow one right here bisects this angle EBC. So that means that angle 3 and angle 4 must equal each other, correct? That's the geometry. That's basically, we're done with the geometry part of it. Now we just have to do the math and set them equal, right? They are equal to each other because this bisects it. So they don't add up to equal anything, do they? They equal each other. So let's do that. I'm going to do the 7 one first. 7x minus 2 equals 6x plus 4. And now we just solve for x. Shouldn't be that hard to solve for x on this. Subtract a 6x from both sides. Add a 2 to both sides. If I'm going too quick, make sure you review it on YouTube. 7x minus 6x is x, and that's a 6, and that's it. You're done. You don't even have to find what that angle is actually equal to. I mean, they could ask you that. What would you do? What if they said find angle 3? Plug it in. That's right. Plug 6 in for angle 3. 6 times 6 is 36, plus 4 is what? 40. So this is 40. What would this angle 4 be equal to? That should be 40 as well. What if I asked you what angle EBC was equal to? It's 80. Everybody see that? What if I asked you what angle ABE was equal to? ABE. 100, right. 100. Everybody see that? Because that whole angle right there is 80, correct? If I asked you ABE, I would be asking what this angle is right there. All right, so if this is 80, this has to be 100 because 80 and 100 is 180. Make sense? So I could ask you all kinds of other things. They made it really, really simple on this. They just said, find x, stop right there, you don't have to worry about it. But I could have said, find angle ABE. And then you would have had to figure out what this angle was, what this angle was, what they were together, and then subtract it from 180, right? So you still had a little ways to go. But I think you should be able to have figured that out. Make sense? I made it pretty easy for you. We got one more question with this picture, so let me get rid of some of this stuff. Let's get rid of that, get rid of that, let's get rid of the 40, get rid of this, this. Okay, and we can get rid of this. We're done with that. All right, let's do another one. Let's go blue this time. So now we're going to take a look at number 16. Let's see, when do we get out of here? 5th 140. Okay, I got plenty of time. All right, this time they tell you, this is almost just as easy. Okay, pretty close to about the same. 4x plus 10. And they also tell you angle 4. So we already know 3 and 4 are equal to each other, so we already determined that. That's 5x. And this time, it doesn't say find x this time, it says find angle 4. Remember what I said earlier? They could ask you to solve for some of those angles in there. That's exactly what they're doing in this problem. But we already got through one roadblock right here. We know that 3 and 4 are equal to each other. So let's set these equal to each other and then solve for x. Alright, so I set them equal to each other. Subtract a 4x from both sides. I get an x equals 10. It's not my answer, though. Question says, find what angle 4 is equal to. Well, we got to take this and plug it in. Plug it in right there to find angle 4. So it's 5 times 10, so angle 4 is what? 50 degrees. There you go. Make sense? Alright. Yeah, if you understood the other one, then this shouldn't have been that big of a deal to understand either. Alright, enough of that. Look at 17. Let me draw the thing out for you. Just draw it real quick. Looks like this. Looks like this. Something like that. Alright, that's pretty close to what it looks like. And let's put some points in here. A, B, C. That's a D. And that's an E. Alright, it asks you to do several things here. Alright, so you got to make sure you read the instructions carefully so you don't forget anything. It says name the polygon by its sides. So how many sides does this thing have? 1, 2, 3, 4, 5. Okay, so it says name the polygon by its sides. So what is what's our first answer here then? It's a pentagon. It's not a triangle. Okay, it's a pentagon. Everybody see that? Alright, so it says name it by its sides. So how many sides? It's a pentagon. Then it says classified as convex or concave. Alright, convex or concave. Well, remember, if I take these sides and if I was to extend, actually, let's do this one. If I was to extend this side right here, it goes through the actual polygon, doesn't it? If it goes through the polygon, then what kind of a polygon is it? It's concave. Alright? If I extended all the sides and they all extend outside the polygon, that would be what? Convex. I saw something on TV. What was it? Was it a commercial or a show or something like that? And somebody said, don't be so convex or don't be so concave or something like that. And then somebody said, was it a commercial? And they said something about geometry or something like that. Or you're so geometric or something like that. I'm like, yeah, geometry commercial. I was so excited. And I thought that was kind of funny. I forget what they said, concave or convex. I don't know which one. But they did refer to that, and they referred to it as a geometry thing. So I thought that was kind of interesting. Anytime they say anything math, I get excited about it. All right, it says, now classify it as regular or non-regular. What does it mean to be a regular polygon, by the way? To be a regular polygon, what must be true? Two things must be true to be a regular polygon. Well, yeah, if it's a polygon, it's automatically closed. So that doesn't mean if it's regular or non-regular. If it's regular, all the what? There's two things that are true. All the sides are equal to each other. Okay, same thing. Or all the what? Or not or, and all the angles must be equal to each other. Do we have that situation here? No, obviously not. Not all the sides are equal, not all the angles are equal. So we call this non-regular. So there's three parts to this answer. You got to have all three to get that problem right. All right, look at number 18. Let's see, I think I might have, what's that, 6 sides? 1, 2, 3, 4, 5, yeah. How many sides? That's a 6-sided though. There's some way, I put this up in another class, and I was trying to figure out, there is a way on here real quick and easy, but I just forget where to go to find it, to like change the number of sides. Like this automatically has 6, but I could change it to 5 sides, and I just don't remember. It's not any, I don't think it's any of these things. I just don't remember how to change the, it's not in there. Anyway, tell you what, I think I might have a pentagon up here anyway. Let's see, do I? Nope. No. Let's see. Do I have any over here? Ah, yeah, I do. There we go. I thought I had one. All right, here we go. Look what they have marked here. They've got this, 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 and this marked. So that means all the sides are equal. Then they have this, all 5 what? Angles equal. So first of all, let's go through the whole thing again. It says name it by its sides. How many sides does this thing have? It's got 5, right? So we call it a pentagon again, right? Both of them are pentagons. Now they look really different though, don't they? That other pentagon looked a lot different than this pentagon. All right, but it's still a pentagon because it's got 5 sides. Then it says, is it convex or concave? What about this one? If I extend all the sides, will any of the sides go through the middle here? No, they won't. So we call this convex. And then it's regular, not regular. Okay. Now the test says not regular. I put non-regular on the other ones. The same thing. It's no big deal. So is it regular or is it non-regular? It's regular because all the angles are equal and all the sides are equal. Okay. So if that's shown, it's got to show. You can't just look at it and say, well, it sure looks like all the sides are equal and it sure looks like all the angles are equal. It's shown right here. It's given to you. So that would be regular. So you need all 3 of those to get that problem correct. That was number 18. All right. That was pretty easy stuff. This wasn't a hard test, was it? If you studied for it and you paid attention and listened to what I talk about in class, it shouldn't have been that hard at all. Now this problem might be a little bit more difficult for you. So let's take a look and see if we can get this problem right. It says, if the supplement of an angle. If the supplement of an angle. Let's stop right there and not continue with that. Let's think about what the supplement of an angle is. A lot of people just say 180 when I say the supplement of an angle. But watch this. What if that was 50 degrees right there? This right here would be the supplement of this angle. Hope you guys are watching over there. I'm trying to help you out. Do you understand that? I'm trying to help you pass this test and do well on this test. But you're not paying any attention to me whatsoever. So look right here. If this was 50 degrees, this right here would be the supplement of this angle. What math do I do to get this angle right here? From 180, right? So it's 180 minus 50, which is 130, obviously, right? What if I didn't know it was 50 degrees? What if I just knew it was x degrees? How would I find the value of this angle right here now? Instead of 50, it's now an x. So it's 180 minus what? It's x instead of 50, correct? Because x could stand for any angle. So this is the supplement of an angle. So anytime you see this phrase right here, the supplement of an angle, what are you going to write? Replace this phrase with not just 180, but what? Say it. 180 minus x, right? So it's 180 minus x. So let's keep going. I'll write out the rest of the words here. Let's drop this a little lower. Give me some room to write, maybe. All right, it says, if the supplement of an angle has a measure, let's just stop right there. This thing right here has a measure of something, right? That means this thing is what? It's equal to something, isn't it? If it has a measure of something, it means this is equal to something. So that little phrase right there, has a measure of, means equals, okay? This thing equals something. Let's see what it equals. It has a measure 78 less than the measure of the angle itself, okay? The measure of the angle. All right, so let's see what we're going to do here. This is the toughest part. That was pretty easy right there, I think. But this says, has a measure 78 less than the measure of an angle. Now let's say the class over there had 5 people less than we have. Let's say we had 20 people in this room. How many would they have? If they have 5 less than the people in here. We have 20. It's not rocket science here. They would have 15, okay? What did you do? You didn't go 5 minus. What'd you do? You went 20 minus 5. If I said we had 5 less, or they had 5 less than we have, right? You would take the number and take 5 away from that number. Now look at this. It says the supplement of an angle has a measure 78 what? Less than the measure of the angle. So it's kind of like saying 5 minus, or 5 less than 20, right? You'd go 20 minus 5. So what would you do here? You'd take 78 away from what? The measure of the angle. What is the measure of my angle? It's x. Remember that? Remember that little picture I drew over there? Okay, that little x was the angle itself. So this is how you set it up. That's definitely the hardest part of this whole entire problem, is setting it up. Hopefully you're paying attention, you're listening to what I was sharing with you, and you could understand what that means. The supplement of an angle, that's that 180 minus x, has a measure of, that means equals. 78 less than, this is the part that a lot of people get mixed up on. A lot of people would write 78 minus. Kind of looks like you would do that, doesn't it? Because 78, you write 78. Less than, that means minus, so you put minus. But you're taking it away from something else. So it's minus 78. That's the key right there. It's where a lot of people mess up. It's 78 less than the angle itself. So let's solve for this. Oops. Let's solve for x now. Let's add an x to both sides. You could have subtracted this x from over here. I like to add the x just to keep it positive. And then let's get rid of the 78. I add a 78 to both sides. Okay, bring everything down. That's a 2x. And that's, what? That's an 8, and that's 225, or 228. Is that right? Or 258. Yeah, right, 258. And then divide by 2, and that's 139. Is that right? 29. Good. Yep. 129. And there you go. And that's what x is. That's the angle. But you're not done, because the question says, I didn't write down the question, but the question says, what are the measure of the angles? Angles. That means plural, right? 2 of them. So that's my angle, right? What's the other one then? Because the other one is the supplement of this angle, isn't it? So it's 180 minus 129, and that's a what? 51, is that right? So there's my other angle right there. So I have 2 answers. My angle is 129, and the supplement of that angle is 51. Those are my 2 angles, so I need to have both of those answers circled. All right. Next problem is really simple. Straightforward. I give you the formula. I give you everything you need to know. Here's the formula I give you. You don't even have to know how to get to that formula. Okay, just know the formula. Actually, you don't even have to know the formula. I just give it to you. And then they tell you just know how to use it. They tell you the radius of this cylinder. This is the surface area of a cylinder. The radius is 6, and the height is 10. This is just plugging and chugging. And you have to find the surface area. This T represents the total surface area. So all I got to do is just plug this stuff in and see what I get. So let's see what happens. 2 pi r h. So the r is 6 and the h is 10. Plus 2 pi, and then it's r squared. So I put the r right here and I square the r. Hopefully you're watching. Let's do this stuff right here. Let's multiply that together. 6 times 10 is 60, times 2 is 120, and then you got just leave it 120 pi. What about this? 6 squared. What's 6 squared? 36. Times 2 is 72, and then pi. Now I just add them together, and that's 192 pi. And I'm fine if you just leave it in terms of pi. You don't have to multiply that by pi. Just keep it like that. It's a lot quicker, simpler, easier, and you're good to go. Perfect timing. We will do chapter 2 tomorrow. Or not 2, but 3. We skipped chapter 2. We're doing chapter 3 tomorrow. If you have your old test, I would bring it in if I were you.